In this session, we will see about an application of stack. The application of stack we have taken is as an Tower of Hanoi. What's Tower of Hanoi? So here we need to move this, the number of disks, there are three disks are there. So this is called source, this is called auxiliary, and this is called destination. We need to move these three disks into the destination with a less number of steps, So now let me show it how we can be moved. Okay. So at first we will move the first disk to the destination, and then the second disk to the auxiliary, and then we will move the destination disk to the auxiliary. So here the rule is always we can place the smaller one on the above of the bigger one, but we cannot keep the bigger one on the above of the smaller one. That's the rule. So now here, what we can do, this smaller one, I can keep it on the above on the bigger one. So I have moved it out. So what I have done over here, we have moved the n minus 1 of disk to the auxiliary, and then we will move the remaining one to the destination. So now this goes to the destination bar. So then we have remaining these two things are there. So now what do we do over here? We will remove the n minus 1 to the auxiliary. So during this time, what happens over here? The source becomes auxiliary, and then the source become auxiliary, and auxiliary becomes source. So this from here, n minus 1 will move to the auxiliary. So this n minus 1 has to move to the auxiliary. Then the remaining one has to move to the destination. So move to the destination. So now here I have remaining only one is pending. So now this source will move to the destination. So here we have perform and correspondingly move the number of disks into destination with a less number of steps. So the algorithm is always we will move the n minus 1 disk to the auxiliary, and then we will move the remaining one to the destination. Then repeat the same steps. But when we are doing the second type of moving, that time the source and auxiliary will be get changed. That's the logic over here. So we will perform this logic by using an recursion logic. What's a recursion logic? We will call the same program within is again and again. Within the same program, we will again and again. So now here we have done the program over here. Here you can see the program. So this is the main program. So we have got from the user that how many number of disks they are going to do it. We in the example we have done for 3. You can perform for 4 or 5 or 6, whatever might be. You can do it. So since we have taken for 3, we will do it for the 3 itself. So n is equal to 3. So we will ask the user to enter the number of disks. So through the n variable, we have got the number of disks. So n is equal to 3. So now what happens over here? A subprogram has been called Tower of Hanoi 3, A, B, C, where A is a source, and then where B is auxiliary, where C is destination. So once we call this program, it will come over here. So this is the this is the Tower of Hanoi program. Okay, source, say n is equal to 3, source, auxiliary, destination. So now what happens over here? So n is 3, and then source is A, and then auxiliary is B, and destination is C. So the n is greater than 0. Obviously, it's greater than 3 is 3 is greater than 0. This comes inside the loop. So then what happens over here? Tower of Hanoi, the same program going to be called once again, n minus 1. So 3 minus 1 becomes 2 over here. So it is 2 over here. And then what happens over here? Source is in the same position. So A is in the A. And then destination. Okay, the second variable going to be destination. So C comes to the second position, and then auxiliary goes to the third position. So once again, the same program gets called once again. So now what happens over here? The same program has been called once again. So now here 2. 2 is greater than 0. 2 is greater than 0. Then it goes inside the loop. Inside the loop. So 2 minus 1 becomes 1. Then source it will be the same position. And then here this program has been called, right? So B comes to the destination. Okay, B. The destination will comes to the second place. So B comes to the second place, second position, and then the destination, the auxiliary goes to the third position. Okay, where in this case C is the auxiliary. C goes to the third position. Okay. So now what happens over here? This program is done. Okay. So once again, the same program gets called once again. 1 comma A comma B comma C. Okay. So the 1 is more than 0. 1 is more than 0. So then here what happens over here? Tower of Hanoi n minus 1. So n minus 1 0. So 0 comma A comma B comma C. So whenever if we call once again, the program will be gets failed. So we cannot do it. So after this line, what this is the next. This is the next line. Okay. So here, which one is source here? A is the source and C is the destination. So move the disk from source to destination. A here in this program, A is the source and C is the destination. So we are moving the A to C. We are moving the A to C. Okay. So and then once we have moved, then what happens over here? This line will be gets executed. This line will be gets executed. So once again, in this case, n is n minus 1. It becomes 0. So this will not be gets executed. So now what happens over here? It will go back to this program. Just go back to this function call. So then here, what happens over here? Tower of Hanoi 2 comma A comma C comma B is done. We have called this program. So next line is going to be this line. So from here in this, which one is source? A is the source and B is the destination. So we are going to move the A is the source and B is the destination. So once this line is done, then what happens over here? N minus 1. Okay, so n minus 1 means what? 1. And then auxiliary will be put it in the first. So here auxiliary is second position. We'll put it in first position. And then source comes to the second position. Okay, so in this function, source and auxiliary will be get interchanged, and then in this position, destination auxiliary will be get interchanged. Okay, so C comma A comma B. So once again, this function will be called once again. So that time 1 minus 1 0. That this will be gets done. It will be there is nothing will be done. So and 1 minus 1 0 will be done. Then come to the next line. Source to the destination. Okay, so now here the source is C and destination is B. So C to B will be gets transferred. C to B will be gets transferred. So this function gets completely done. That tower of finite 2 function is completely done. So it will goes to the corresponding third function. This function, main function, 3 comma A comma B comma C. So now this line is completely done. This line is completely done for 3 comma A comma B comma C. So now here, what happens over here? The next line is going to be source to destination. Here source is A and C is destination. So A to C is done. Then the third line. And 3 minus 1, 2. 2 is there. And then source and auxiliary are get interchanged. Source and auxiliary are get interchanged. So B comma A comma C. So once again this function will be get called and n minus 1. So once again what happens over here? B will be have it over here. Same source. And then here destination auxiliary get interchanged. Destination and auxiliary get interchanged. So once again, an n minus 1 becomes 0. 1 minus 1 becomes 0. So this line will be gets done. It goes to the next line. It goes to the next line. So here source is B and destination is A. So it will move from B to A. And then once this line is done, it will come to this line. So whereas here the n is equal to 1, So 1 minus 1 0. This line will not be get executed. So then what happens over here? It goes to the second function, this function. In this function, it will go to the print statement. So here the B is a source and C is a destination. It moves from B to C, and then it will go to its last line. So 2 minus 1, 1, 1 comma A comma B comma C. So then 1 minus 1 0, that is done, and it will move to the A to C. Okay, this is the last line. So uh, uh, to understand this concept clearly, you can see it over here. So at first this function gets called, then this function will gets called, and then it comes to this function. So then 1 minus 1 0, so nothing will happen. So once 1 minus 1 0 becomes happen, nothing will happen. Go to the next line. It goes to the next line. Okay, so 1 minus 1 becomes 0. So in 0, if 0 is 0, this will not get executed at all. So that is the into mark over here. So then what happens over here? So it goes back to the one function itself. Then move from source to destination. Source is going to be always source is first variable and destination is last variable. So 1, 2, 3 gets moved. Then the third line gets executed. N minus 1, 0. Then this function also into mark. So this is completely done. So it goes back to over here. So it goes back over here to go for print statement. 1 to 2, source to destination. Then the third line. Okay, so 1 comma 3 comma 1 comma 2. Then for 1 minus 1 0 into mark, and then print statement source to destination 3 to 2 and 1 minus 1 0 into mark. So when this is done, it will go back here, and then it will go back to the main program, main third this function. So this function, the first statement is completely done. Then the second statement, printf statement. So 1 2 3 gets moved up. Then it goes to the right hand side. So 2 comma 2 comma 1 comma 3. Then for that it will be happen for the right hand side. So this is a recursive function. We keep on repeating again and again and again and again. And then completely this 3 comma 1 comma 2 3 is completely finished. So this is the first step. At first we'll move the first disk to the third disk, and first to second disk. So second auxiliary, and then destination to auxiliary, and then source to destination. Then auxiliary to source, and then auxiliary to destination, and then source to destination. This is how we can do it for 3 disk. Okay, thank you for watching.